On a project with 10 people, 80% of the work done is typically completed by just 2 of those people. This is because of something called the Pareto rule, which states that 80% of the outcomes of a project comes from 20% of the inputs, and the typical software team is 10 people. So if you're a software engineer, chances are you have at least 2 of these 10x developers that are just carrying the team in the sprint. You know, that one guy that's just assigned himself to all the tasks hasn't been resolved, and you just look at the sprint board and you're thinking, how the hell is he doing so much? And when you read his task, you have some idea of how you would code it yourself. Maybe it's 40, 50 lines long, and you go and have a look at his pull request and see that he's managed to do it in 1 line, and it's really easy to read. We know these people exist, so how is it that they go from being mere mortals like us, taking a couple of days to solve something, to solving something in hours, and also having high quality code? So in this video, I'm going to cover the acronym you learned at school that can 10x your productivity, how to get the solutions nobody else thought of, and what masterful code actually looks like and why you can achieve it. Well, one of the big things holding us back is, if you ever worked on a task and you get halfway through and you start thinking, something about this just doesn't seem right, and you go back and you check the task and you realize that what you're implementing looks nothing like what the task actually described. So you basically have to go back to square one and start again. I'd refer you to something that you probably would have learned in school. Read the full question, just because it's a common thing that humans fall afoul of. We're not robots. And when you're under pressure, especially if you're a software engineer, you've been told, oh, this task is going to take 6 hours, and you start getting up to 5 hours and you're thinking, oh, I'm not getting much closer. That pressure gets to you. And once you get into the flow of something, you can end up going on a complete tangent and end up with something that looks nothing like what the original question was even asking. So how do we solve this in school? Well, they tell you as you go through, make sure that you write down what you're doing, explain yourself, show the steps, even maybe make a plan before you start the question. Well, we're not in a maths exam. We don't have an invigilator looking over our shoulder making sure that we're not cheating. In fact, we're incentivized to Google the answer if we can, because the faster you can get something done, the better. Your tasks probably look something like this, maybe a little bit more information, maybe a little bit less, and this is where you can then go out and immediately just start. You can load that into your mind and just start trying to implement a solution. But I mean, you're just setting yourself up to fail. Sure, this might work for tasks here and there, but I mean, really, you'd probably be better suited to break it down into the steps that you're going to take, because you're going to run the risk of veering away from what you were actually trying to do. And one of the easiest ways that you can do this is to actually ask ChatGPT to help you come up with that plan. Now, it's not going to understand the system, and depending on the kind of work you're doing, you probably want to genericize what you put in. So take out any company code or specific language related where you work. But just spending a couple of minutes before you start your task to have a plan means that you've almost got a rubber duck, except it's actually giving you things that you might not have thought about. So what it's given me here is kind of broad and non-specific, but if I was to ask, so if I give it something more specific, like the unit test framework that I use, which normally I do this all in one conversation, so it already knows what my tech stack looks like and what frameworks I use. But you'll see here that it immediately starts giving a pretty good step-by-step, okay, here's some boilerplate, here's what we expect to see. And then maybe I'm already thinking about, okay, which tests I need to implement. Well, okay, I'm not going to, by myself, think of all the ones that are possible. So ChatGPT is a fantastic tool for thinking about edge cases and just double checking that, oh, I hadn't thought of that. That's worth implementing. So if we ask it, you'll see, look, it's exactly what we're after. And then what I'll do is I create a scratch file in my IDE, throw these in as a checklist, and then just go through, tick them off as I go. It's even given me here examples of how I can do each category of test that is recommended. If you have a strong plan before you start, you're going to spend a lot less time just dithering about and getting stuck into doing things that aren't going to provide value, which the chances are the main thing that will provide you value in your job is being able to do tasks efficiently. But then a good question would be, what about those solutions where it just seems like it's things that I never would have thought of, the really outside the box? Well, there's a strategy for achieving that. It's going to require some practice, because you're not just going to become some software architect genius overnight. But at this point, we're assuming that, okay, you've got your task and you've planned it out, so you already have an idea of where you're going and what's going to happen. But realistically, a plan is a massive simplification. Software engineers are paid what they're paid because what they're solving quickly isn't. But there's no point sitting there being paralyzed with complexity of working out what the perfect way to solve your problem. Just take your plan and follow it. I had a task recently where I had a class that had the information that I needed, and then there was a location on the other side that needed that information. So it was like, okay, well, this feels pretty simple. All I need to do is get information from here to there. Well, no, it wasn't that simple. This information was hidden in a bunch of asynchronous tasks that were passed through services and all sorts of layers. And then somewhere up here was the connecting class, which then passed back down through its own layer system. So the connection needed to go all the way through these layers and all the way back down again. And some of these functions had multiple references, so if I made changes to the parameters that were passed through, it would have cascading effects on more classes in adjacent places. And it just felt like it was going to balloon out massively, and it did. And when you look at this jumbled mess and you think, oh god, I'm about to change half the system just to pass some information from one place to another, it's intimidating. And you think, oh, there must be a better way of doing this. But yeah, sure, there probably is, but you haven't worked it out yet, and that's part of the process. Now, what you could do here is go to the drawing boards, sketch it out like this, which I do. I do sketch it out like this. I made a video about using Excalibur. But fundamentally, what solves the problem is doing the hard work straight away. So okay, my initial pass of solving this was I was like, okay, screw it. It's going to touch a bunch of places and I'm going to have a bunch of references that I'm going to have to update. Let's just get to it. And I set myself 2 hours. I was like, okay, let's go, music in. And at the end of the 2 hours, I'd managed to get the path working so that I could get the information across the system in a way that wasn't good code. I mean, it was spaghetti code, but it did work. And I was like, okay, well, fundamentally, this was all my task required. It's done. But would this get through code review? God, no. And I mean, even if it would that be the kind of like masterful coding that we're aiming at? No. So I had these changes and I was like, okay, well, now I know what the footprint of this is going to look like. Worst case scenario, I have a very bad solution, but I have a solution. So I stashed the changes and now I have a better understanding of what classes I'm going to impact, what the data looks like as it passes through multiple different objects, and the exact trail of where it goes and where the link is. So my next pass, I was able to create an object that meant that I was able to bypass a lot of the peripheral classes because I actually understood the code through the entire journey, not just in the key classes that I were going to make changes. Now, when it came to actually getting it back down to where I needed that information, there was no nice solution for unlinking these classes because they needed this data as well. And I only knew that because I'd gone through and actually done that first pass. But I mean, the difference being is that on this second go, I realized, actually getting the information to the top, that's not a problem. I can skip a bunch of steps that I was going to do otherwise. Getting it back down, okay, I've tried some other things, it hasn't worked, that's fine. This is my final implementation. It's a lot cleaner than the changes I stashed earlier. Had things had gone wrong and, this didn't work out, it's fine. I could have just rolled back, tidied it up, and gone with my original changes. But no, on the second pass, I found something way better because I'd already done it before. Don't be afraid to have a couple of dirty solutions before you go for a final implementation. And if anything, try not to get too caught up with, okay, how can I architect this solution? One of the benefits of coding is that you can prototype things quickly, fail, learn from those mistakes, and then implement a better solution. And the beauty of it is that you don't immediately lose your previous solution. You have both, and then you can compare them. And if your new solution's worse than your previous one, delete the new one, go back to the old one. You can hold all of your changes. Git is an incredible resource. Even if you think you've done a hard reset, it backs up, I think, up to a week's worth of your work. There's no way in hell that you've lost your previous implementations, and sometimes they are better. When we talk about these top performers who produce far more code than anyone else and it works, you look at it and you go, God, I have no idea how that works. And then you've got somebody else on your team who's probably just as productive and you look at their code and you can understand it. I would make the argument that the guy that's writing code that anyone at any level is doing a better job than the guy who has the coding pattern that nobody's ever seen before that maybe is the best use case, but I mean, if nobody's seen it before, how maintainable and expandable? Realistically, good code relies a lot on your team's knowledge base and preferences. That's why every software team has its own coding standards and styles. There's a really nice acronym for this, KISS. Keep it simple, stupid. It's easy when you're a beginner or even a mid-level to look at some code and go and get inspired to go and find the most niche and different way of doing something. But in reality, chances are you're not the only person working on a code base. If you can take something really complicated and make it simple, that's the sign of a masterful coder. You're not just becoming an island of knowledge where nobody else knows what you're coding. You're making it so that you're not the only person that can work on that piece of code. Just because you can write something in one line instead of 4 lines doesn't mean that you should, because that one-liner might not be that readable. And if you've got entire classes filled with these things and somebody comes along who's never looked at a class before and is trying to fix a bug that's somewhere in your code, well, they're going to have a really hard time if they're having to spend 5 minutes looking at every line just to get their head around what's going on. So how do we do that? Well, this article covers it nicely. The obvious one, keep your code simple. How do you do that? Use descriptive names, so don't just call numbers X and Y. Give them something meaningful. Don't have gigantic methods that are just 50, 60, 100, 200 lines long. Try and split them up. That doesn't mean that every single line should become its own function. There's some people that do that as well. Have it in meaningful chunks. A really good way of sticking to this is just think of the single responsibility. Is my function now doing multiple things? If so, okay, let's split that into subfunctions. These are the high leverage things that are going to push you into that higher productivity. Having a plan you follow. Solving it the first time quickly, having maybe just a bad implementation so you actually understand all the places that you're about to touch, so then you can plot yourself a better route the second. People are going to then look at your second implementation and think, oh god, I wouldn't have even thought about it because this is the third time I've thought about the problem. I've solved it twice already quickly, and as a result, now I know the best way to do this. I know what works and I know what doesn't work. And then lastly, keeping it simple so that you're just making it look effortless. Okay, maybe it was something difficult, but you've made it look simple so that other people in your team can understand. People are going to notice that. Now, this advice is all well and good, but it's quite general. Everybody watching this video is going to have different things that could move the needle for them. So if you want personalized guidance, I offer one-to-one coaching in the description, so I'll leave a link below. I've got a video about the tool I used in this video to break up how you can solve problems, and this will make finding those unique solutions a lot easier. So if you click this video here, I'll show you how to do that. Hopefully that video helps. Cheers.